Now we're on our keynote address on saving the world's rarest dolphins with AI and drones. Doesn't it sound interesting? Well, we've got the co-founder and technical lead, Maui 63, Tane Van Der Boon. Tane specializes in bridging the gap between innovative technologies, ideas, business, and social good. Thank you so much, Tane, for joining us today live on the World AI Show Australia. It's great to have you. How are you doing, Tane?
Good, thanks. Thanks for having me.
Pleasure. So with this, I'd now like to present the stage and screen to you. Over to you.
Awesome, thank you. So hi, everyone. I'm Tane. I'm the CEO and I suppose the technical guy of Maui 63. I'm one of the co-founders as well, and that leaves me on the board too. So I'm just going to bring up presentation. Through. So Maui 63, we're a not-for-profit, a full charitable trust, and our mission is to protect marine life with innovative technologies. And then I suppose the beginning of our story is the Maui Dolphin. Cool. So if we talk about the Maui Dolphin here in New Zealand, it's the most endangered dolphin in the world. There's only 63 left, so it's critically endangered, and probably it is at the brink of not being able to come back and restore its own population. And then the problem that we saw was that there's actually no data, and so there's lack of data. We don't actually really understand where these dolphins are and where they go. And if you talk about the two key threats to Maui Dolphin, fishing being one of them, not so much of a threat anymore due to some regulations that have been put in place. But then the other one is toxoplasmosis. Toxoplasmosis is actually cat poo entering the water. Cats obviously are not native to New Zealand, so introduction of a virus into their habitat that infects their brain and then results in death. So if you think of both of these key threats, they are geolocation related. So what we wanted to do is put something together that we could start to understand, where these dolphins were, where they are over time. Currently, they do get surveyed, but it's very infrequently. So we're talking boat-based surveys. If we're lucky, once every 2 years, more frequently, once every 5 years. And then the other thing that used to happen, which can't anymore, was people sitting in an airplane spotting them. It's quite unreliable. It's, you're going off. I think I saw a dolphin from a plane, but also the only plane that could do that in New Zealand with the right type of viewing areas has been shipped to Australia. So other than that, it's very hard to collect this data. So our solution comprises of three key components. So we've got the computer vision, artificial intelligence. So what that allows us to do is automatically detect dolphins as we're flying around. And it also, we're running it on the edge. So we're running it on the drone itself, which means that once the drone spots a dolphin, it can actually ask the pilot if they would like to follow that dolphin. And by following that dolphin, we can start to understand how they move and who they hang out with. And this is really important for other things that we're working on, like predictive modeling, which I'll talk about a bit later. The second component is our UAV, the drone. So it's remotely piloted. It can fly for up to 6 hours at 140 up to 160 k's an hour. And it can fly currently up to 50 k's away from the pilot, and we could extend that up to 100 k's. The last component of the project in its current state is our data reporting and visualization. So this is essentially once the drone lands, we compile all the data and then feed it up to a cloud service that can be used. A key thing that Maui 63 is trying to achieve is to make sure this data is made publicly available to everybody. So this means researchers, this is fishers, this is regulatory bodies, government, whoever needs this data, we believe should have access to it and access to it for free. So if we talk a little bit more about the AI, and for anyone who wants to get a little bit technical, we're running this on a NVIDIA Jetson Xavier AGX in the drone itself. At 1080p video, we're getting 35 frames a second, so we're quite proud of that. Computer vision at that speed is leading edge. And for people who want to recreate what we're doing, we're running a YOLO V4 Tiny model modified, but that's the base. With a TKD and then backbone for specific performance on the Xavier unit. we're getting 90 to 93% accuracy for the 1 meter dolphins at about 120 meters wide. So we're quite happy with that. Further to this, we've actually just upgraded our camera, and we've got a 9,000 by 4,000 odd pixel camera that we'll be integrating for speedy stills as we fly along as well. So the drone, it takes off and lands vertically, and then it flies like an airplane. That's how we get the endurance that we need. It's got about a 5 meter wingspan. You sort of see it there on the right. It's quite big. It flies, like I said before, up to 160 k's an hour for up to 6 hours. We have full video link up to 100 k's from shore, currently 50. We set up a predefined flight path. So the drone pretty much flies autonomously. It takes off. It does its flight path that's been determined, and then it comes back in for a landing. We've got our camera system, 50 times optical zoom on board, and we've also got our infrared on board as well. And another protocol called ADS-B, which allows us to actually see other airplanes in the area and allows them to see us. So if we talk about the data and the data flow, we record our live detections on the drone. Then we, upon landing, we upload that data into the cloud and it's stored. So all of our video data, the complete flight, is actually stored forever. Because again, we want to make this available for other people to run other models and do other cool things with this video footage and still footage that we're collecting as we fly. After it's been uploaded, we reprocess the video with more intense models that require more compute or run slower, which hopefully allows us to better refine the data that we've collected, and then we munch that back in with the GPS data. In this process, we also pull individual frames and key components of the video out, and we label them with the machine. So they're pseudo-labeled autonomously by the computer vision models. And then we human check that data, and then we actually feed that back into our models that are retrained and then re-uploaded to our drone for our next flight to hopefully improve our precision going forward. Once all that data is merged together, is the other stream, it turns back up into this platform vision, which is provided by our friends at Rush. You can see here a little demo of that platform. So essentially it provides not only a list view, but a map view that you can see spottings and locations where they were, and then you can also preview them. I'll just quickly show you a little video and I'll talk you through the different stages, but this essentially shows you those three components coming together. So that's the large drone. This is actually one of our pilot flights. We're getting set up on the beach. So we need that vertical takeoff and landing because there's actually really large cliffs behind us. So we need to be able to avoid them in all sorts of different wind conditions. That's the famous Maui Dolphins there. And those are those cliffs that you can see that we need to fly over as well. So essentially, when we're flying over, we've got a downward looking view, and we also do area searching as we search through the ocean. So the camera's looking and staying in a specific area and then searching left to right as we go. So we can hopefully capture the dolphins as they're coming up to the surface. This is a little preview of some of the other machine learning that we're doing to predict, to help inform us of where we can fly. And here you can see a little demo of the computer vision model identifying dolphins, and that footage the model had never seen before. So it's actually quite a bit better at spotting dolphins in the oceans than humans are. And here you can see it turning up in our final platform. So I just wanted to quickly finish up with what our next steps are and what our next plans are. So our key mission right now is getting a continuous monitoring program in place. So this means flying on a regular basis and covering the whole Maui habitat on a regular basis. This isn't so much a technology challenge, but more of a flight permission challenge. It's quite hard to get permission to be able to fly where you can't see a big drone, especially a drone at our size, because we don't want to kill anybody, hurt anything, or damage anything. So You have to build up a lot of experience, policies, processes to get that all approved. Our next step, which is something we are working on now at the same time, so we wanted a unique identification of dolphins with using facial recognition algorithms. So there's a couple of ways we're going to capture this data. One is when we actually see a dolphin while we're flying and our drone decides to follow it, it actually flies big circles around it, which gives us a nice angled in view. And then we've instructed our pilots to zoom in on the fin, because we've got 50 times optical zoom on board, and they can get really nice side-on shots of those fins. This data is going to be what's going to enable us to do unique identification. So we'll have a model that pulls fins out of our flight data set autonomously, and then we'll run a different model on top of them using facial recognition algorithms to hopefully uniquely identify each of the dolphins. And what we're also working on at the moment is an app. So we can feed in citizen science data as well. So if someone sees one of these dolphins when they're out fishing or whatever in these areas, which happens more frequently than you'd expect, considering how few there are, we can actually hopefully help them identify it and create more engagement in that space, the citizen science space. The last thing, and what's really important to this project, is actually the predictive model implementation. So this is really important because once we've collected data, say over a year, we know that these animals are quite habitual. So hopefully these patterns are the same and they're frequent. And with a whole lot of other data inputs, we can actually start to predict where they're going to be and when, which really helps to make policymakers to make data-driven, informed decisions of how to best protect these animals. That's it from me, and opening the floor for any questions.
Thank you so much, Tane, for that. What a brilliant presentation. It definitely gave us a lot of perspective of what is happening in the space of AI in terms of the dolphins which are getting tracked. So Tane, you're doing firstly a brilliant job. Let me give you kudos to you on that.
Thank you.
Also, Julian from the audience is saying a big thank you to you. So with that, Tane, I'd really like to thank you from our side for joining us, and keep spreading the joy and cheer all across, and keep doing the good work you're doing.
Thank you. Thanks for having me.
Pleasure.